Now let's look into the descriptive statistics, the measures of central tendency. Now to understand that descriptive statistics is of two types. One is the measures of central tendency and the measures of dispersion. When we say measures of central tendency, it actually means that how the data is spread across the mean of the data. And the measures of dispersion is basically when we look into the type of range, the deviation, standard deviation, the variance, and the interquartile range. And then likewise, the central tendency is where we look into mean, median, mode. And I have also added harmonic mean and geometric mean just to make sure that you are able to answer the interview questions. Okay. Now, whenever we look into the measures of central tendency, whatever process you are working with, you will be dealing with a lot of numbers, numbers related to the output, the number related to the input to any processes. Whenever you are designing any machine learning algorithm, some data comes in and some data comes out. So you have to basically understand the central tendency of all the data. So how do we make sense of our out of these numbers, right? And that's where statistics, these type of statistics will help you. When it comes to descriptive statistics, as I mentioned, it is descriptive statistics. Sorry, when I talk about statistics, statistics is basically descriptive statistics and inferential statistics. Now, before I move into mean, median, mode, descriptive statistics actually helps us in understanding the data. So whatever data you have, whether it will help you to understand the data, but inferential statistics will rather help you in predicting or inferring the data about the data. So it's actually how you infer about it. Now coming to the mean, median, and mode. So as we all know, mean, median, and mode. So I will quickly go through the slides to make you understand that what is mean. Very easy. I will not take much time of yours. So if we have three data set, mean is actually the average value of the data set. So in here we have 28 plus 32 plus 40 by 3, which is 33.3. Now, one of the way we can represent mean is by this formula, which is summation of x by n. Summation of x is nothing but the sum of all the values divided by the number of values. So in here you can see 144 plus 98 for $144,000 plus 98,000 plus $204,000, followed by some numbers and then $100,000. And there are 7 numbers, so you divide by 7, so you get $170,571.53. Okay, so this is the sample mean salary. Now, one of the things which we'll talk about is why mean is getting affected by outliers. Say, for example, if you see this data, your sample mean was somewhere around $170,000, right? But whenever a very big outlier or extreme data is getting introduced, what you see is the entire mean is getting shifted towards the extreme value. So now with the introduction of only one data, the entire mean of $170,000 is getting changed to $268,000, right? So mean is affected by extreme values or outliers. Very important question you will be asked in interview. Whenever we will learn k-means clustering, we'll see this question again, where it will say why to not use k-means cluster. And there also you'll give the same answer that k-means cluster actually use means, and means is affected by extreme values or outliers. So this is a drawback of k-means clustering. Now, what is the median? To keep a check on outliers, what we can do is median is the positional average, okay, and refers to the middle value of the distribution. So whenever you get some data, what you do first, you have to arrange the data in ascending or descending order, and then you take the middle data for your analysis. So in here, what you see is you have certain numbers, and if you calculate the median, you see now the median is $155,000, and it is not affected by the outlier.
It should be 177,000, right? Median here.
No, you have to arrange the data first.
Okay, yes. Yes.
$98,000, and then followed by the ascending order. So you can arrange it 198, 100, 140.
Yes. Yes.
Okay, so this will be $155,000. Now, one question which is asked is, what if we have, in here we have odd number of data, 1, 2, 3, 4, 5, 6, 7. So we took the fourth data, which is in the middle, right? After we arrange them. So we'll look at it with one example. So whenever we have, odd number of data, what we do is we take the middle two values and then sum it and divide by 2. We'll go through this in an example. What is mode? Mode is the most frequently occurring value in the data set. So for in here, you see that 32 is occurring 3 times. So that's why, since it is occurring most frequently, the mode is going to be 32. Right? So if we have a sample of 20 groups with which was selected at random, and we have all these values, right? So if we want to find the mode, what we can see is there are 2 modes in the data, 2 and 4, each occurring 6 times. So you can have more than one mode in the data set. Okay. And you can also have no mode in the data set. If you have, say, example 1, 2, and 3. So none of them are occurring frequently, right? So mode is 0. So this will also be asked in some interviews. Now, practical uses of measures of central tendency, mean, median, mode. How does it help us in statistics in the machine learning perspective? So it helps us to understand the spread around the data. So what is the spread of the data? We will be able to understand, right? So what is the mean of the data? What is the median of the data? What is the mode of the data, right? So it will help us to understand the spread. Also, we will be able to replace missing values in the data analysis. For example, if you have a column with salary and 2 of the, so the sample size is say 1000 and 2 of the salaries are missing, and you cannot delete those records saying that these are missing value, I want to delete it, because you don't have much data, right? So what you can do is you can replace the missing value of the salary with the average value, okay, or the median value, right? So this will help us to replace the values in the data analysis phase. Next is to showcase performance of players across their careers. So for example, if you have again salary data, what you can do is you can bucket them with different designations like managers and senior managers and directors, and you can showcase how these guys have average salary or median salary or whatever data you want to showcase. You can also study salary spread across the company. You can understand like how much disparity is there within organizations. So for examples, countries like India, US, you can see a lot of spread of salary. The lowest and the highest value is very high, right? There is a huge disparity. But if you see European countries like Norway, you can see that there is not much of a salary difference from within colleagues and within juniors and seniors. So they have an even spread of salary. So it will be able to, so through statistics, we'll be able to study the salary across the company. Now, next we will look into the introduction to descriptive statistics. So we have basically looked into the measures of central tendency. Now we will look into the measures of spread. Before we move into measures of spread, you have any questions?
All clear.
Okay. So measures of variability basically provides information about the degree to which the individual scores deviate from the average value in the distribution. So we have three common measurements of dispersion. Here we have four common measures of dispersion, and these are range, interquartile range, we have variance, and we have standard deviation. All of us have studied this in our class 10 or plus 2, and I will quickly go through each of them to make you understand that this is very easy and we will be able to solve this without much of a challenge. So range is something which is the difference between the highest and the lowest amount. So for that, you can arrange your data in from ascending to descending order, and you can basically subtract the minimum and the maximum value. So this will give you the range of the data. So for example, if you have two plant managers are asked to record their plant production, and these are the 5 days of output. So plant A has these units 15, 25, 35, 20, and 30. Plant B has 23, 26, 25, 24, and 27. And if you want to find the range of the maximum and minimum, so the maximum which you have is 27 for plant B, and the minimum is 23. So the range is 4. Likewise, you can calculate for plant A, which will basically be the minimum, which is 15, and the maximum, which is 30. So the range is 15. So we can say that plant A has a lot of deviation of production of units. Now variance is actually the average of the square distance from the mean. So average of square distance is basically when we will try to understand this with an example. So here you can see that we have a data set which is 206, 76. I'm sorry, I missed the data part. Okay, so the average deviation from the mean is 394. So what you see here is we have to basically deduct values from the mean. So I will come through it with an example. Just a second. Okay, I can give you an example with 100 and let me open an Excel. Okay, say for example, we have data points like 104, 98, we give a number 90, and then 104. And so what we have is we can calculate the mean of this data, right, which is 100. Now the mean is 100. And from here, we will try to find the deviation from the mean. Say for example, here, so this deviation from mean is basically sorry. Okay, so what we can see is this is the deviation from the mean. So when we deduct 104 with 100, we get a value 4. When we deduct 98 from 100, we get -2, -10, -4, and 4. So this is actually the deviation from the mean. From here, what we need to calculate is the squared value, right? So from here, we will try to calculate the squared value. So what we can do, we can do this. Right? And we can try to find the sum. And then from here, so what you can see, this is actually the variance. This is the variance in the data. What we have done is when we have 5 data points, we took the mean of the data point, right? And from that mean, we basically calculate the deviation. So this is actually the deviation from the mean. And then we took the square of the deviation and then divided by the number of terms which we have, which is 5. So if you go back to the slide, what we have calculated is first the variation, and we squared the value one by one and added them and divided by the number of terms which we have. So we have the variance here. Now coming to the standard deviation is nothing but the square root of this value. So in here, whatever we got, 21704, we have done the square root. So if we try to find out the so the standard deviation is going to be 5.51. Any questions?
What is the difference between variance and standard deviation? I know that, like you said, standard deviation is square root of variance, but why do we have those two separate measures?
Why do we have this separate measures? Yeah, very good question. Now we are able to. So what does this variance means is variation is actually the deviation from the mean, right? And whenever you do a variance, you are basically doing a square. Say for example, if we have all these data points in centimeters, so eventually once you perform this square, you are converting this centimeter to a centimeter square, right? Which is actually changing the original dimension of the data. Okay. And whenever we do a square root, what happens is that centimeter square will also change to centimeter, right? So this basically helps us to find the variance, find the deviation from the mean with the same unit of measure, right? And whenever we perform standard deviation, if you see standard deviation is less than the variance, so it's easy for us if we have a lot of data and a lot of standard deviation. So it gives us a more compact view of the dispersion of the data.
Okay, so in this case, intuitively it feels like in most cases standard deviation will be used. So in what cases we prefer variance over standard deviation?
It actually, whenever you do an analysis, variance and standard deviation both are measured, right? But the thing is, if you want to make sure that you are reporting the result in the same unit, you showcase the result in the standard deviation.
Okay, so they both roughly denote the same thing, but standard deviation is in the same units as the data.
Right.
Okay.
Okay, so one question was if you can explain variance again. Sure. So variance is nothing but, so I will go to the formula first. Okay, so if you see this formula of standard deviation, so forget about sample. Now focus on the population. What you see, the formula of standard deviation is root under of summation of x minus mu square by n. What does it mean? It means that you are basically taking the difference of each of these points. So x is basically these points. This is x, right? This is your x. You are basically taking the, and this is your mu. I can write u. So this is basically the difference of each of the values from the x, right? So first you can see that I have taken a difference of x minus u, sorry, x minus u, which is basically 4. And then 98 minus 100, which is minus 2. And then 90 minus 100 minus 10, and so on, right? So you got all the deviation from the mean. Now there is the sign of summation. Summation means addition, right? So you add all these values. When you add, sorry, you took a square of it. You took a square of the values, so 16, 4, 100, 16, 16, and then you add because you have a summation. Once I added it, what I got is 152. And then I took the variance. Variance is basically 152 divided by the number of values. The number of values is n. So I divided it by the number of values and it comes to 30.4, right? And if you want to calculate the standard deviation, you just need to perform an under root on top of it. So once you perform an under root, you got 5.51. So this is your variance and this is your standard deviation. Understood?
Yeah, Lanka.
Okay. So, yeah. So what is standard deviation? Standard deviation tells how close the values in a data set are to the mean. So for example, when I have a standard deviation of, 2, it means that I am 2 places either on the left or on the right. Now, for example, if I give you an example that every day I commute to my office and it takes 20 minutes to reach. Some days it might take 50 minutes due to traffic in Bangalore. And some days when, I reach early office within 12, 13 minutes because at the morning time, generally the traffic is less, or even in the afternoon time, the traffic is less. So when I say that my standard deviation is 2, it means that I reach within 2 minutes, okay, either on the left or the right. So it can be 18 minutes or 22 minutes. So in most of the cases, I reach office within 18 to 22. So my standard deviation is 2, which basically tells I am deviating 2 units from my mean. My mean is 20 and deviating 2 minutes. So it is from 18 to 22. So majority of the days I will reach with a standard deviation of plus minus 2. Understood? So the data with a small standard deviation will look something like this. So here you can see it is just deviated, I believe, 3 units from the mean, right? So whenever we draw a conclusion on a lot of data, what we generally see is majority of the day. So when we go through these classes, majority of the time we will join at 9 a.m., right? So majority of the time we will be on the mean 9 a.m. But at times we can join early. At times we will be like 9:01. At times we will be 9:02, 9:03, and very less instance of time we will be joining at 9:30. or very less instance of time will be joining at 8:30, right? So majority of our data will be positioned around our mean. And this is how the standard deviation will tell us that if after completing 70 hours of our, statistics and machine learning, we see that, I joined majority of the days between 9:01 or 9:03. So I can say that the mean is somewhere around 9:02. So I will be I have joined this class at 9:02. Okay, so this is actually standard deviation. Now, if you have standard deviation with a very high deviation, okay. So for example, at times I might join 7 minutes earlier. At times I join, 7 minutes later. Okay, so you can see the spread of the data. You can see the spread of the data. So that's why standard deviation is part of measures of dispersion. So it basically tells you how dispersed the data is, right? Now, standard deviation formula has two parts to it. When you try to understand what is the difference between a population and sample, in population, for example, if I want to take the average age of this class, so I know exactly how many students are here. So if I go to participant, there are approximately 14 people who have joined. Now I can take n as 14, right? And if I find the average age, I'll be getting an accurate answer. But now when it comes to sample, whether it's sample variance or sample deviation, the formula changes. The formula in the denominator, you have n minus 1. N is the number of observation. So this is actually is a part of inferential statistics where we have at least 15 to 20 minutes solving this question or solving this to make sure that we understand why this is n minus 1 and why not it is not n. For now, you make sure that you know that in whether it's sample or population, the formula changes in both the cases, right? Population has a denominator of n and sample has a denominator of n minus 1. Very important. You will be asked this in an interview. We will go to the intuition behind it in the inferential statistics class. Now comes the third part, which is the interquartile range, or rather the fourth part, which is interquartile range. Interquartile range describes the middle 50% of the value when they are ordered, right? So for example, if I have 2, 4, 4, 5, 6, 7, 8 as a data set, what I can find is the median. Median is the middle value, right? And from here, we have divided this into two parts, one to the left of 5 and one to the right of 5. To the left of 5, you can see there are 3 numbers and the middle position is 4. So the median of these three number is 4. So this is the median and we call it the lower quartile. Likewise, we have to the right 6, 7, and 8. The middle value of 6, 7, and 8 is 7, and it is actually the median of 6, 7, 8. So we call it the upper quartile. So in a data set, you can divide it into quarters, which we call quartile. We'll come to the conclusion again with an example. So what happens is when you divide the data set into 4 parts, into 4 quarters, you have the first quartile between first 25 and the second 25. You have the median or the second quartile in between the data set, and you have the third quartile between the third quartile and the fourth quartile. So this is called the third quarter and the fourth quarter, which is called the third quartile. So the interquartile range is basically Q3 minus Q1. So Q3 minus Q1. So the interquartile range is 3 in this case, 7 minus 4, which is 3. Let's understand this with one more example. So you have a sample data set like this. You took the mean, which is the middle value. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 data set, okay? Or 11 data point. So the middle position, which is the 6th one, is going to be the median. So the median is 17. You took 17, and now to the left-hand side, you have 1, 2, 3, 4, 5. 5 values. The middle value is going to be 6. So 6 is your lower quartile. Okay. And then you have 5 numbers to the right, 20, 25, 40, 41, 46. The middle value is 40. So your interquartile range is basically 6 minus 40, which is 30. Okay. Now, if you see the interquartile range, which is going to be 6 minus 40, which is 34, right? Your median is 17. Apologies for the diagram. The median is 17. The lower quartile is 6. The upper quartile is 40, right? And the interquartile range is Q1 minus Q3. So you can plot an interquartile range using a plot called Box-Whisker plot. Okay, Box-Whisker plot. In the Box-Whisker plot, what you can get is the interquartile range, which is the lower and the upper quartile, the median of the data, and the whisker. Whisker are basically the quarters which we are not taking into consideration. And you have the minimum and the maximum value. So this is how a Box-Whisker plot is shown. Okay, so this will be asked in your interview question. Now, what is the benefit of quartile? So from the benefit of quartile, you can understand that you can have a sense of the maximum and the minimum value. You can understand how the median is positioned. If it is, exactly at the middle of this box, it will basically mean that the median and mean are same, right? But if you see the median is to the left-hand side of the mean, you will basically understand that a lot of data point is actually in the lower side of the data, right? And if your median is towards the right, it will basically mean that a lot of your data is to the higher side of the data. We'll come to this again. But before that, if you have any question, do let me know. Now, coming to the practical uses of measures of spread. A measures of spread gives us an idea of how well the mean, for example, represent the data. So whether the data is very evenly distributed or it is not evenly distributed, we will be able to understand it using the measures of spread. If the spread of the value in the data set is large, the mean is not a representative of the data, as if the spread of the data is small. So if you have a large data set, right, there's a very good possibility that the mean will not be able to answer your question because it is very sensitive to outlier. So to check that, we basically use median and mode, right? So if you have a small set of data, the mean might work. Okay, it might not work. But if you have a large data set, the mean is not going to work. So measures of spread basically gives you the outliers in the data. So it gives you a figure of how you can figure out if there are outliers in the data. It will help you to standardize the data with respect to mean, right? And it will also monitor control system for not normal behavior. Say, for example, you have created a model which basically looks out for any fraud in the data set, right? And from the output of the data, if you see that a lot of transaction has happened on the higher end, okay, and from one particular geography, you will be able to understand the data is not right and it is skewed to some part of your data process, and you will be able to quickly analyze it and monitor it using your visualization. Now, next we will come into the measures of shapes in the next lecture. Before that, we will go through some question answer. If you have any question, unmute yourself. You can ask your question, or we can have a small quiz where you can answer a few questions. And then if you have any doubts, or if you see that you're not able to understand any of the terms, do let me know. Before I start, you have any question?
No, I'm not there.
Okay. So we'll quickly go to Okay, please use the chat session. If you have any question or doubt, do let me know. There is no wrong question. There is no silly question. Okay. Once you guys have joined, 8 participants has joined, I will start the question. Okay. Shall we start? Anyone else yet to join? Okay, let's start. You have 90 seconds to answer this question. Very easy. Find the mean of the following set of numbers: 1, 1, 1, 2, 4, 5, 5, 7, 8, and 12. Please answer it in Menti. No need to type on the chat. You can use your Menti to enter the answers. 6 participants have answered. Please don't type your answers in the chat section. This is a very fun way of going through the slides. Don't want to make it boring, because I absolutely hate any online learning session if it is not interactive. Okay, 8 people answered 4.6, 1 5, 1 5.6. So the correct answer is 4.6. I hope this was easy. And those who have answered 5 and 5.6, I think this was a silly mistake. Don't worry about it. Let's move on to the next one. You can see the question in your chat room. Okay, Sachin with 900 points. Good. Next, we'll come on to the next one. Please look into your Menti. The second question. Answer fast to get more points. Mean gives a distorted picture of the data due to the presence of. 30 seconds to answer your question. Very easy. I can see a lot of folks answering very quickly. Very good. So every day we will have this Menti session. Since this is a very basic descriptive statistics, you might see that this is very easy, but we'll go through the interview questions like this. Time's up. And mean gives a distorted picture of the data due to the presence of extreme values or outliers. Okay, so 0 value is not an answer. You can have 0 as an average when you take mean, right? So at times it might happen that you have a data set which has 0 in it. For example, the number of hours you have watched Netflix, it can be 0, not a problem. But it cannot be you watch 23 hours of Netflix. It's a very extreme outlier data, right? It's not correct. Okay, let's look into the leaderboard. Good going, good going. Okay, Sachin on top, Let's look into the third one. Look into your Menti. Is it possible to have no mode at all? Is it possible to have no mode at all? Understand with a data. If you have a data set, do you think that it can happen that there is no mode at all? If you remember the definition of mode, you will be able to answer it. 9 answers. Where are the rest? Yes, 11. Good. Let's see what's the answer. Is it possible to have no mode at all?
Alankar,
Yes. Yes.
I think this is a controversial question that is it possible to have no mode at all? Because there are two definitions. Some authors say that it is possible and some authors say that it is not possible.
Yes.
This is a
Yes,
controversial
I
question.
understand that. Totally understand that. But in statistics with machine learning, what industry says is that you can have no mode at all. Say, for example, it might happen that you have a data set. Okay, you have a data set where you are taking a column as gender, male and female. What we generally do is that we take a sample of odd data sets, say for example 11 data, and try to find which gender is the most, male and female. Okay, so if you get a 5 and a 6, your answer is going to be 6 with the mode, and you are going to replace any 12th data with the mode value, which is the female value, right? Because we cannot take the mean or a median for any categorical value. Categorical values are values which are not numbers. It are male, female, or yes or a no, happy, sad, neutral. So these are categorical values. In that case, mode is used. So in data science, generally in the machine learning space, in industry, we follow a scenario where you might have no mode at all. Okay, there is a clash because we deal with a lot of data. So we'll go through this again in the inferential statistics part to justify this. Okay.
Yes.
But again, this is a very good question that this is controversial. Okay, coming to the fourth one, I believe this is the fourth one. Good, very good. We'll come to the fourth one. Very easy. Look into your Menti. Answer fast as possible. What is the convenient way of visually displaying the data distribution through their quartiles? Which plot will you use if you want to see the quartiles, the distribution of quartiles? Okay, within 8 seconds, you all have answered. Very good. Everyone has voted. The correct answer is box and whisker plot. Box and whisker plot, as we have shown in the PowerPoint presentation. Box and whisker plot is used to showcase any interquartile range or quartile data. Line graph is not used, and scatter plot is also not used. So this was just a demo of how we are going to make that session interactive, and you also can stay on top of whatever you have learned. From next day onwards, we will start the class with a small quiz of 5 questions, whatever we have learned in the previous class. So next class, we will see 5 questions from the descriptive statistics part, right? It will help you to brush up the any topics which you are lagging or which you have gone through, right? And before that, we will go through a small doubt clearing session to understand if someone has not understood any part of the previous class. Okay. Okay, congratulations, Sachin. You can send whatever sweets you want to all of us through Swiggy.
Just a question on interquartile range. With mean, median, or mode, we understood, okay, this is the deviation that's happening from the observation or the data that we have with us. Now, we have the interquartile range as 34 and box and whisker plot with that. We understand, okay, we have this. Now, how exactly this number 34 is representing for us? I mean, what kind of a meaningful data can we take out of it?
Okay. So to understand, if you remember, we talked about standard deviation, where you see a lot of these data are concentrated towards mean, right? So when you take any data set which is large enough, okay, you will follow a pattern that they are at times in statistics we call normal distribution, right? So this will be a normal distribution. And majority of this data, when we look into 90% confidence interval, 95% confidence interval later in the inferential statistics part, we will understand that majority of this data actually is within a confidence level.
Okay.
And this confidence can be, so just by looking into the data visually, we'll be able to understand if there is any challenge with my data. Got my point? If there is anything which I need to understand before I dive into the data set. Say for example, here you see the median and the mean is having a significant difference.
Yeah.
Okay? Like the median is somewhere around 18,000 and median is 16,000. Had the median been near to 18,000, we would have understood that this data set is very standard, normally distributed, and we no need to perform any big statistical techniques on top of any column.
Okay.
So this is what this quartile will basically tell you. So how the data is divided into different quarters within your data set.
Okay, got it.
All right.
Yeah.
So we will, when we visualize this over Python, we will have more understanding when we have first-hand experience with the data.
Got it. Thank you so much.
Yeah, sure. But that's a good question, because a lot of us have these type of questions when we go through them for the first time, and then slowly when we develop these knowledge, we are able to understand and relate to what it was taught in the classes. Okay. If you have any sort of references which you can find, you can just let me know that whether it's related to quartile or quantile. So you will get to all of these terminologies in the subsequent sections.
Okay, sure. Got it. Thanks.
Yeah. So before I start, so this is my LinkedIn. If you want to, if you have any questions, you can directly reach out to me over LinkedIn. If you want me to, you to refer to any of the jobs where you see I am a mutual connection, I will help you out. So we can connect over LinkedIn as well. Okay, so we will go through 2 descriptive statistics questions at the end of the class. And this is not a quiz, so there is no timer. You can take your time to answer. Okay, we'll quickly move to Python. So this is my Python notebook. If you want to follow along, you can also open your Python notebook. It is going to be very easy. I'm going to be very slow. So you don't need to worry about if I'm going very fast. Okay, so today we will basically look into mean, median, mode, and then we can look into standard deviation. We can look into variance as well, and interquartile range.
So in the presentation, we saw that there was a mention of harmonic and geometric mean as well. So are you going to look at them right now or later on?
No, later. So for now, we will just look into the basics of it. But harmonic mean and geometric mean are also very easy. So we'll go through it in, when we talk about skewness and kurtosis.
Okay.
Yeah. Okay, so we will first look into mean, median, mode, standard deviation, and IQR, variation in IQR. If you want to follow along, you can open your Jupyter notebook or any Python notebook. Okay, so let's create a list. I have created a list with 3 numbers. Let's take one more. So we have 1, 2, 3, and 3. Right. If possible, I would ask you to open your Python notebook, follow along me, so that you don't have to again revise it, when I share this notebook. And then if you have any challenges, you can just let me know right now. So the debugging time will also be very less for you. Right? I will go very slow. So some of the very easy topics I will cover. Sum, you can see the sum is 9. Let's find the length, because we will require length in order to perform standard deviation and variance. Right? So now you have the sum and the length. Now you can say that, okay, we can easily find out the variance mean by just dividing 9 by 4. And if we try to find the mean of, say, A, right? And if I hit on run, obviously there will be a error. That mean is not defined, because there is no built-in function in Python for finding out the mean, right? There is no built-in function. There's no built-in function to find out the mean in Python. So what we need to do, one thing which we can do is, we can just, I'm going very slow. Stop me if you are lagging behind. Right? This is what we can do. But this is not an ideal thing. Right? I want to print the mean. I'll obviously get 2.25, but this is not ideal. Right? I'm going very slow. So this is not the way to find out the mean. Obviously, you can do it for 1 or 2 instances, but to loop it through, or it is not the ideal way of finding any statistical data. So what we need to do is we need to import the library, which is statistics. Okay. Once you are done with the classes, I would request you to go to the document of statistics. Okay. I will, when I share this notebook with you guys, I will try to, mention the link where you will be able to see the document, so that you can get to understand what all other packages are present within this, or what all other functions are present in this package. Now, if I want, I can find out the mean, right? Because mean is present inside statistics. When I just give mean of A, since it was not able to infer from which package should I know, or in which package I look into the function mean, right? It was giving me an error, name mean not defined. But inside statistics, you have a function called mean, and you will be able to calculate the mean. What is len A? Len A is basically length of this list. Okay, you see there are only 4 elements in this list, right? So length of A will be 4. If I change this to 5 elements or 7 elements or 10 elements, the length will also change accordingly. Okay. Even if it is a very silly question, very easy question, do ask me. There is no right answer, right question or a wrong question. Okay. Okay. No problem. Okay. So now we have found the mean using the library or package statistics. Now, you can easily now figure out that we can use this statistics package, right, to find out anything we want. We are able to get the median as well. Okay. How the median was calculated? You have 4 elements, right? This is an even number, 1, 2, 3, 3. Now, if you have only 3 numbers, say 1, 2, 3, the median would have been 2, right? But now, since there are 4 elements, you take the middle two values, and sum them. So 2 plus 3 is 5, and then divided it by 2. So 5 by 2 is 2.5. So the median is 2.5. Any question? If you are not able to understand, please let me know. Hope you are all following along me.
Yes, all good.
Okay. Even if it is very basic, give it some time. There are few folks who are new to this domain. There are few folks who are non-technical. I want to make sure that they are all comfortable with our pace. Okay. When it is time to run, we will run. Okay, clear. So you have mean, median. If you want to create mode, right? We can create mode as well. So just change median to mode, right? If I hit on run, 1, 2, 3, 3, right? So median, why 3 comes into picture? Because 3 is mentioned 2 times, right? Now, since median mode is done, we will look into range now. Okay. So say, for example, if I want to find the max, yeah.
For mode, like if we give 1, 2, 3 values in a list, then also this mode is calculating the value as 1. So
yes, because it is taking the ascending value. As I told
smallest.
You that,
it is taking smallest value.
Yes. Why I'm telling you that since you said that this is a very debatable topic, when you go to the industry and try to find the answer, you will basically get majority of the answers. What I told you, that this is not the mode, this is not the correct way of approaching it. You should not take it, right? So there are 2 answers to this question. One is theoretical answer and one is a practical answer.
Yeah.
When you look at the practical point of view, it makes sense that none of them are actually standing out. So you cannot take one as the mode. So this is what
Actually, it is not taking the smallest value. It is taking the first value, first instance.
Yeah. Oh, yes. Yeah. Right. So that's why I mentioned ascending. It's taking the ascending value.
Yeah.
The first value. Yeah. My bad. Okay. Yeah. Do post these type of questions, because a lot of us, generally shy away asking this type of questions. But even if one of you are able to answer, the purpose is solved. Now we'll try to find the range, right? What is range? The minimum and the maximum difference. You see the range is 2 because the maximum value is 3 and the minimum value is 1. Now we can find out range also. We can next look into the standard deviation. For that, we'll use the same package. This is statistics, right? So when I type statistics dot and then a tab, you will be able to see all the functions which are inside the statistics library, right? Statistics dot and hit the tab button, right? You get all the functions which are present inside the statistics library. We will be heavily using this library in order to perform our hypothesis testing to find out, inferential point of view from a data. Right. So for this, we will be basically looking into standard deviation. So where is your standard deviation? Right. Your standard deviation is here, STD EV, right? And you pass the list. So it will easily calculate your standard deviation, which is 9.574. Any doubt, any question? If you're getting any error, do let me know.
So is it giving, I think, sample standard deviation, right? Not population standard deviation.
This is giving you the population standard deviation because your population is defined here.
According to formula, just if we take formula of standard deviation, what they're using, 1 by n or 1 by n minus 1.
This is calculating 1 by n.
Okay.
Okay. So this is your normal standard deviation. Okay, we'll come to that how to perform on sample in the inferential statistics. As I said you that.
Ananta, I do have a doubt here. So there is another function called PSTDEV. So yeah. What's that difference between PSTDEV and this STDEV?
PSTDEV is, I believe, 1 second.
Maybe that's the population.
Okay, I think I took the wrong one. Yes, this is the population standard deviation. You're correct. Right, this is the sample standard deviation. This is right. This is the population standard deviation. Thank you for pointing it out. Because when we are dividing it by population, it is basically dividing it by value 4, right? So the value 4, when we divide it, we get a.
Yes, this is population only,
value
because I calculated
it. Divided by 3, we get a higher value. Right. Thank you for pointing this out. Okay, likewise, can we calculate for variance? Can you guys calculate for variance and tell me the answer?
It's 0.91666.
Okay.
Yep. Same.
Right. 0.9166.
This sample variance.
Yes. Any questions? Any doubt? Okay, no. Can we find out the quantiles? Please do find out the quantiles. If someone is not able to follow along, do let me know. What's the answer?
1.25, 2.5, 3.0.
Yes, 1.25, 2.5, and 3.0.
How is the calculation done here in quantiles? Like in this package, how do they calculate?
Okay, how do they calculate the quantiles? Can anyone answer?
I think in this case they are taking left side as 1, 2, and 2.5 maybe.
Yeah.
First, they are calculating the median.
The median, right?
And after that, the left side of it, the median on the left side of the median and the median
Right.
on the right side of the median. So we will get 3 quartiles.
Yes. So first we are calculating the median. So 2.2 and 3 has a median of 2.5. Right? So it will stand somewhere around here. 2.5 will stand in the middle. Right? And from there, we are calculating the median of the left hand side and we are calculating the median of the right hand side. Okay. So the calculation is.
Yeah, in this case, if the 2.5 is in the middle, then on the left side there is 1 and 2, and if we take median of it, it needs to be 1.5, right?
The calculation is not happening that way. Like 2.5 plus 1 by 2 is different value than 1.25.
Okay. Yeah, sorry. This is quantile. I'm very sorry. So in statistics, we are basically looking to the quantile here. Okay. And whatever we have learned here is the quartile. The difference is the R. You see?
But in quantile here, n is equal to 4 is by default. So it is calculating quartile only. Here n is equal to 4 is given by default in this quantile function.
Yeah.
So it is calculating quartile only.
Right.
If you see definition of quantile, like you click like put your cursor inside the bracket, and then press shift tab.
Yeah.
So here is it n continuous intervals, and if you expand it plus on plus. Here it is says that n equals to 4 for quartiles.
Right.
So and n is equals to 4 is set for default.
I think it is just dividing the range into 4 equal parts and not looking at the mean actually. Probably, I guess.
Because the definition of quartile and quantile is different, right? So in that case, what is happening is it is basically taking the mean of the middle two numbers, that is 2 and 3, and basically fetching you 2.5 as the median, right? And then from there, it is giving you the quantile value of 3, right, which is here, and the other quantile value, which is 1.25. But why this 1.25 comes into picture? Okay, let me calculate it. Okay, you can look into the next one. By the time I calculate, so what's left? We have the IQR, which is left. Can you find out the? Let's take one more example just to understand the previous one. Say, for example, if I give you something like 70, 85, 90, 98, 104. Let's take one more, 105, 107. Can you guys try with this and just pasting this over chat? Here I have given you odd number of cases, right? So with odd number of cases, there is no issue. We are able to get the quantiles as well. 98 is the median. Why 98 is the median? Because there are 3 numbers to the left and 3 numbers to the right, right? So the middle value is 98. So 98 is the median. And then out of the rest of the 3, you have 70, 85, and 90. You get 85 as the mean. And you have 104, 105, and 107. The median is 105. So the quantile is 85, 98, and 105. Now, can someone tell me what will be the interquartile range here?
Yes, I got the answer. I can't tell how they are calculating.
Yeah.
Like suppose the length of that data set is n.
Yeah.
So what the formula they are using is n plus 1 by 4. Suppose we want to calculate first quartile. Then they are using the formula n plus 1 by 4. For here, it will be like 4 plus 1 by 4 means 5 by 4. That is 1.25. So 1.25 times. So 1.25 means first term will come 1 plus 0.25 into 2 minus 1.
Right.
The second element minus first element. So then it becomes 1.25. So now I remember the formula. Like this is the formula which is used for calculating quantiles.
Yeah. So I'll give you the calculation here. So those who are not able to follow, don't worry. I'll give the calculation here so that you can also follow along with this notebook when I share it. But thanks for asking and thanks for getting the answer. Can now someone tell me what is the interquartile range here? IQR?
20.
The IQR is 20 because as we have seen in this slide that IQR is basically the difference of Q3 and Q1, right? Q3 and Q1. Now, if you go here, what you see, this is your Q3, this is your Q1, and this is your median. So basically, if I do this, it will be better for me. And then if I do Q of 2, right? If I do Q of 2 and then a Q of 0, right? Going very slow. This 20. Any question? Anyone has any question? Now, how to plot this? How can we visually see a box plot just like this, right? So we will do some importing. We can import matplotlib, and for that we have to do a pyplot. Okay. So matplotlib is a library from where you basically take help to plot any type of data. Okay. And for better visualization, we will be using Seaborn. Right? Seaborn. Okay. Please follow me. If you have any question, do let me know. Okay. Ran without any issue. Now we can do one thing. We can use Seaborn to SNS.boxplot, and then we have to pass the parameter, which is C, which I'm going to plot, right? We are assigning C. You can directly pass C, not a problem. And we'll use the show function to showcase the result. My bad. Box plot. Okay, so this is your box plot. This line here shows the median. Now, if you carefully see, okay, first, if you're typing, do type it, and then I will explain this to you. For non-technical people, don't worry about any of the libraries and packages. This library is only used, these libraries are only used to plot data. Okay, these are visualization library. So why I've imported matplotlib? Because I want to show the result to you. Okay, matplotlib and Seaborn are basic libraries which we use to visualize any type of data. Okay, so we have written import matplotlib.pyplot as PLT. Okay, because we don't want to use this name again and again in our code, so we have transformed this to as PLT. So if we use PLT anywhere, it will basically mean matplotlib.pyplot. Okay, and then we have imported Seaborn, which is again a visualization tool, which will give you better visualizations. And from there, we have used SNS. So as if it is actually an alias which we use, like a nickname which we use, right? So we give it as PLT, as SNS, right? Import pandas as PD, right? So PD is the alias which you give. Now we have SNS, which means Seaborn dot box plot, and then you pass the parameter C. C is nothing but the list. C is nothing but the list of data. Okay, so you passed all the data here. Okay, Y equals to C, because I wanted to show. So this is actually a best practice which we follow. Okay, and then once this is created, once the SNS box plot is created, Seaborn box plot is created, I want to show the result in a Jupyter notebook, right? So that's why I have written plt.show. Okay, matplotlib.pyplot show. So we want to show the result. So this is how you are able to see the result. Now, if you carefully look into this, what you can see is our mean was 98. If you remember, our mean was 98. Sorry, our median was 98. Right, our median was 98. So that's why significance of y equals to c is nothing. You can pass c also. Okay, you can pass just c. This is a best practice which we use in the industry to make sure that we are passing all the values in the y variable. Okay, because there is x and this is y, right? If you see, this is y variable, this is x variable. Yeah, this is y variable, this is x variable. So all the values are in y, right? So that's why we are passing y equals to c. Okay, there are other ways also, but this is what we follow in the industry. Okay, you are passing all the list in the y variable or in the y side to it, okay, of the graph. Now the median was 98. Okay, so you see this line is actually telling you this is the median, which is 98. So if you follow this, the median is somewhere around 98. Okay, and then you have the highest value, which is somewhere around 105, or sorry, IQR Q3, which is 105. So that's why it is corresponding to 105. And the lowest value, sorry, the Q1, which is the lower quartile, is somewhere around 85. So this is showing you 85. Okay, so this is how your interquartile range will look like. Okay, so whatever we have learned today, mean, median, mode, standard deviation, variance, and IQR, we saw how to implement this in Python. Obviously, there are many ways we will implement this in Python, but this is the most basic way you can implement all of these descriptive statistics here. Any question, do let me know.
Alankar?
Yeah.
What I think is that NumPy calculates quartile with different formula, statistics calculate with different formula.
Yes, yes.
And SNS is doing with different formula, because I did SNS.boxplot with y is equal to a. Then the box plot is Q1 different than what we are calculating through statistics package.
Right. So the underlying way how you see this is very different. Okay. And when we do inferential statistics, we will actually build our code on top of NumPy, because this is not ideal situation to create anything on top of list, right, in any of your functions. But now we have only created this with a small list, because this is just the first class. So those who are from the non-technical background will not be able to follow along if I use complex NumPy matrices. Okay, in the inferential statistics class, we will slowly develop from a list to more complex data structures with NumPy, which is actually the way we create in industry. And in there you will see a little difference, and it will basically look something like this, okay. And I will also tell you what's the difference between what we created here and what we created in NumPy.
Because what I studied in statistics, when I studied, then there what formula I learned was this one only, what statistics package is using, but not NumPy even.
This is a pure basic mathematics class. If you want to transition from mathematics to statistics, this is how they tell you.
Yes.
So if I go through complex NumPy programs right now, then you will not be able to understand the underlying features, and you will be getting lost with the visualization part. Okay, nothing to worry about. We have to do a lot of things. We have to build inferential statistics on hypothesis testing. We have to solve a lot of use cases. We will look into ANOVA, t-test, right, z-scores. So in there you will require NumPy as the base of your array. Okay, any question? use the chat window to ask the question, or you can unmute yourself. Okay, so I will be sharing one. I'll look into one PDF which I have for basics of statistics, which is 3 or 4 pages. If you get time, please go through it, and we can discuss if you have any questions on top of it. So this is that is actually a PDF file. Just give me a second. Check. Okay, so this is the file which I'll be sharing with you. This is actually a basic statistics PDF file. If you get time, please do read through it. If not a problem. We will discuss each and everything in the class. You can keep it as a reference. Okay. Okay. So now if you can move on to Menti, I will share one. Testing it in chat. Only 2 questions. Okay, anyone left? 13 participants, including me. So I can expect 2 more answers. Okay, so next. Okay. Everyone done? Okay, so these were the only two questions which I had. Now coming to the first one, what is the standard deviation of measurement? 444 444. Can someone tell me what is the standard deviation? Standard deviation is the deviation from the mean. Now what is the mean of the numbers? The mean of the number is 4. So what is the deviation from 4? 0. There is no deviation. It is on 4, right? Had the mean be say 3, the deviation would have been 1, right? But in this case, the mean is 4. I'm repeating again, the mean is 4 because if you sum all these values, which is 24, and divide it by 6, you'll get 4, right? So 24 divided by 6 is 4, and standard deviation is deviation from the mean. The deviation from the mean is 0 because 4 minus 4 is 0. I hope you remember this. If I put 4 over here, if I put 4 and again a 4 here, right? And the mean is going to be 4, right? So what you can see that the deviation from the mean is 0, right? So the standard deviation is also going to be 0. I hope I am able to answer this. Next, the sum of square deviation of measurements from their mean value divided by the number of measurements is called standard deviation or variance. See, I have not asked you anything related to square root. I'm just asking the sum of square deviation, the sum of square deviation. So if I go back to the slide, standard deviation is basically this root, right? So I am not asking you anything related to the square root. I'm just asking the sum of square deviation of measurement from their mean value divided by the number of measurements is called. So this basically tells you the answer is going to be variance. The answer is going to be variance because standard deviation is basically the root under of variance. Okay, the root under of variance. So this is actually variance. Variance is the average of the square distance from the mean. Average of the square distance from the mean, and standard deviation is the square root of variance. Okay, very easy question, but you guys got a bit deviated from the actual definition, right? Any question, do let me know. This was the first class of your statistics. Intentionally, we wanted to keep it very low and very slow, just to make sure that you are able to understand. Yeah, the quantized solution, I will be giving you the solution with a diagram, okay, visually, so that you will be able to understand. So let me create a whiteboard for you and share this when I share the notebook with you, right? I will have to add a few comments here and there, because once you want to refer this at the time of interview, or if you want to do your homework, you can refer this with the comments. So I'll be sharing with you this slide which I have right now and the Jupyter notebook along with the comments, right? And I will also make sure that the calculation is present here, okay, within this notebook, right? Okay, guys, thank you. If you have any question, do let me know. Use the WhatsApp chat group to ask any query if you have, and do send me if you have any you'd want any link over LinkedIn through a job recommendation, I'll try to help you out.
Just one thing, when we say variance or standard deviation,
yeah,
it's actually the deviation of individual, I mean the mean of deviations of the individual data points, right?
Yes.
Okay.
Yes.
Yeah.
Why we are basically interested in standard deviation and variance, because when you have a lot of data on the number line, okay, this number line will be huge enough.
Yeah.
But you want to visualize this. When we look into inferential statistics, we'll understand this is something called a normal distribution. And basically everything and anything in this world basically follows a majority of the data follows a normal distribution. Normal distribution means that majority of your data will lie within the confidence interval, which is 90% confidence interval or 95% or 99%. And all of them are concentrated towards the mean. Okay. So that's why we are calculating variance and standard deviation just to find out how much deviated it is from the mean. Okay. Okay. Whenever we answer a question like, so what do you think? How much percentage you will get in the exam? So you cannot say that I will get 90%. You will say that I might get 90% and then plus minus 3%. It means you might get 93% also. You might get 87% also. And the mean is going to be 90. So you have a confidence that I will get somewhere around 87 to 93 with the confidence of say 90% or 95% or 99%, which we will understand how we get into this type of confidence interval. Okay, so that's why variance, standard deviation, all these descriptive statistics are required when we want to switch into the inferential part.
Okay. Do we always say this with respect to an entire data set, or do we go to individual data points? Like when you say variance, standard deviation, you say with respect to a data set.
Yes. When you showcase your result to your stakeholder, you might be from a company where you say 90% of our customers are returning back to our website, right? With the confidence of 90%. Okay. That 90% customers or for example, 90,000 customers every month are returning to your website, right? With 90% confidence interval. And we have say, for example, plus minus 1% standard deviation. So this is one metrics which we are trying to justify through your statistics. The other metrics can be the revenue which we get from these returning customers are say, for example, 50% of our total revenue, right? And then you say 1 or 2% of standard deviation.
Okay.
Understood?
Okay. Yeah.
So individual metrics can have their own individual standard deviation and variance. And your overall data set can also have, but ideally we look into individual metrics.
Okay. Yeah, thank you.
Right? Okay, so any questions, do let me know. Any domain specific questions, do let me know. We'll try to solve many problems, real-time industry problems which we face. I will also tell you how to approach a machine learning problem starting from the inception of the problem with your client to the delivery, how to deliver this, and where statistics is required, in which scenario statistics are required in a huge number, and where data manipulation is required to a lot of extent, where it is not required in a lot of extent. You will eventually understand with time that only 20 to 30% of your entire workflow is actually modeling part, which is the machine learning model which you write, or basically the codes which you write to develop a machine learning model. Your entire day of a data scientist will majority go into looking into the data, cleaning the data. If you are an individual contributor like me, so I don't have a team right now because I'm developing proof of concepts of projects, so the products. So you have to understand entire situation of whenever you get a data, how to find statistics out of it, how to create a database which can capture all your data, how to create a model which will basically work with the trained data which you have created with the data model, and how to deploy this in an enterprise AI system, whether it's Azure, AWS, or Google Cloud Platform, and how can we host this through a web application, how does a machine learning model interacts with a web API through API. Okay, so this is all the holistic picture we need to understand if you want to become a full stack data scientist. If you want to be a data engineer or a data analyst, you have your own set of roles and responsibilities, which we will see in subsequent sessions. I'll also try to give you examples of how a product is developed and how, as a data scientist, you will be challenged to, to maintain your product, to scale up your product, how to get into innovation side of the product, and what is the difference between a product manager and a data scientist. What are the roles and responsibility of each of these specific individuals who are part of a data science team, how to build a data science team from scratch. So these are all the aspects which you have to understand from an industry point of view. We'll make sure that with each of these mentee sessions, which you have every day, 2 or 3 mentee sessions, you understand each of the concepts and can bring in knowledge which you can retain for a long time. And we will make sure that whatever we are teaching you is actually aligned with how interviews are conducted. And we'll be sharing a lot of interview questions for different companies as well, so that if you give interviews on any of these companies, you can scan through the questions which they ask.